Hi Andy, good morning. This is again Dr. C.H. Kiran Kumar dealing you the machine learning part. Right, today we are moving on to the new chapter called as linear models. Linear models, unit number 4. Unit number 4. Right. Here, linear models. We already learned what are called tree models and rule models. So what are the major differences between these? Tree model, rule model, and now linear model. My dear friends, here we are going to use geometric models of mathematics like lines, planes, etc. Right, see here. Most often assume that instances are described by D real valued features, and thus we have x is equal to R power D. If we use D real valued features, thus the space would be x is equal to R power D. R power D. And if the data is plotted on a D-dimensional, if two-dimensional, see, what do you mean by two-dimensional? X and Y axis. If X, this is X axis, and this is X axis, and this is Y axis. See, this is called two-dimensional graph. And here we say D-dimensional graph. That is 3 dimension, 4 dimension, n dimensional. So if it is a 2-dimensional, we call it as a line. If it is more than a 2-dimensional, it is called plane. Hope you understood my difference, right? Right. So a data is plotted on a D-dimensional Cartesian coordinate system. We can then use geometric concepts such as lines, planes to impose structure on this space in order to build a classification model. Right. We can easily see, for example, we have already seen something like this. If our data is like this, we can draw a line passing through our data, and then we can find a system for this. See, that is what we can. Alternatively, we can use geometric notation of distance. See how much distance is there between. Actually, some of our points lie on our points lie on the line also, and some other points do not lie on the line. So then we'll take the distance. This is called distance. This is the distance, and we average the distance and find out which line is called the best line. See, this is how it is. See, any lines can be drawn. No, this is one line, this is another line, this is another line. So that way, number of lines can be drawn, but we will be using. Now, this is what we are going to learn, right? Similarly, on the basis of 2 points, suppose if these are all the points we have, suppose another point comes, suppose another point we have to predict whether this is correct or not. We can now see 2 points are nearby points to this, whether they are positive or negative. In that way also, this linear models can be used. This is right. Models that can be understood in terms of lines and planes, commonly called as linear models. Models that can be understood in terms of lines and planes are commonly called as linear models. Right? We need to learn some minimum basics of mathematics regarding these lines and planes. Let us see this. If x1 and x2 are two scalars or vectors, what do you mean by scalar? Scalar is nothing but a constant. Vector is a two-term, 2, comma 3. See, this is x coordinate, this is y coordinate. That is called a vector. Vector of the same dimension and alpha, beta are arbitrary scalars. Then alpha x1 and alpha beta x2 is called a linear combination of x1 and x2. This is just terminology, my dear friends. There is no need to worry about this. And what do you mean by linear function? Linear function is f of alpha x1 plus beta x2 is equal to alpha into f of x1 plus beta into f of x2. This is just a notation. The function value of a linear combination of inputs is a linear combination of their function values. See, if it is linear, automatically its function also become linear. As a special case, if beta is equal to 1 minus alpha, if beta is equal to 1 minus alpha, we are taking the weighted average of x1, x2. That is the meaning of. So, if beta is equal to 1 minus alpha, it is nothing but we are taking the weighted average of x1 and x2. This is what, no, conclusions, right? Linear functions takes particular form depending on the domain and codomain of f. If x and fx are scalars, it follows that f is of the form fx is equal to a plus bx, also called as mx plus c. Normally, our mathematicians used to guide us like this. Y is equal to mx plus c, where m is called slope and c is called intercept. And this is also shown in terms of vector. Ela chupistam vector form lo y is equal to, see here, x coordinate, y coordinate plus x coordinate comma y coordinate into x. What is this? This is nothing but slope. Slope is generally represented as y coordinate by x coordinate. Suppose if I say slope is m is 2 by 3, then I will represent this as 3 comma 2. And the point of intersection is represented with x comma y. So this is called, this is how we show in a vector form, Right. Now, even if you can see this, this is a two-dimensional, y is equal to mx plus c is a two-dimensional line. But whereas if you see a three-dimensional, that is plane, that is totally different, my dear friends. In that case, what we do is, see here, see this is, if x is equal to x1, x2, xd is a vector and f of x is a scalar, then f of x is equal to a plus b1 x1, b2 x2, etc. This is also called, it is also of the form a plus bx, but b represents b1 x1, b2 x2, b3 x3. See, in this case, there is no y. This is x1, this is x2, so this is x3. See, this, this is how we represent plane. This is called plane, my dear friends, plane. Where b is equal to, b1, where b is equal to b1, b2, etc., bd. So this is how it is plane. So this is what we are going to learn in this particular chapter. Hope you understood. These are all the basic concept of mathematics, right? Let us see some lines. Right. You can see this. The slope of the line is related to any vector whose y component divided by the x component in the slope of the line. See, also called this is the slope. So angle wise ga kuda maatladukovachu. We can talk like angle wise ga kuda we can talk of this. Right. Anyhow, right. So this is given as 2 minus 1, a line through 2 minus 1 with slope 2 by 3. 2 minus 1. This is 2 minus 1. This is 2 and this is minus 1. 2 minus 1, a line is going through 2 minus 1 with slope 2 by 3. What is 2 by 3 here, my dear friends? 2 by 3 means what? See, and x-axis 3 and y-axis is 2. See, approximately this is what? Slope. 3 by 2 by 3 slope. This is y-axis and this is x-axis. Right. The line through the point 2 minus 1 with slope 2 by 3. This is theta. This is the angle. The value of m tells us how the dependent variable changes for every 1 unit of increase in the independent variable. Normally, we write independent variable here. X-axis. And dependent variable here. On y-axis. Right. So this is how lines. Okay. Next, we will see. Right. These are all the examples of lines. This is one line with slope. This is the slope. With another slope. This is slope. If the slope gets varied, slope means 0 to 360 degrees. So automatically slope defines the direction. Defines the direction also. Direction. So this is how it is. See, the slope is right. This is another slope. So these are all some examples of lines and some examples of lines on two-dimensional space. On two-dimensional space. Two-dimensional space. Let us see what do you mean by three-dimensional space. See here you can see this is x-axis. This is x-axis. This is y-axis. And another axis is called z-axis. Right? So these are three axes are there. No, we can definitely visualize two-dimensional. But if you want to visualize the three-dimensional space, you have to think of a space where you have three dimensionals. For example, if you take a house and a corner, if you take the wall, this wall, and there will be another wall, and here height also will be there. Right, this may be one axis, this is the another axis, this is the another axis. So if you think in that way, so then you will be thinking of a space. So this is called plane. This is called plane. So this is how it is. Right, some more examples of planes. Planes look like this. These are all the planes look like. Right, we are going to learn such things. Right, hope you understood, my dear friends, the basics of mathematics. Basics of mathematics. Right, in machine learning, now we are going to learn what are called linear models and what is the differences between the already just learned like tree models or rule models. What are the differences between linear models and tree models and all. In machine learning, linear models have got a great impact because of its their simplicity. They are very simple. Why they are called simple? Linear models are parametric. Parametric meaning that they have a fixed form with a small number of numeric parameters that need to be learned from data. So data nunchi manu will be learning some numeric parameters. Numeric parameters very important. Numeric parameters. Now this is different from tree models as their structure is not fixed. In tree models, we used to have, right, we used to find the best split in order to get label, feature. Labels are very important. Best fit, best split. But here we are not concentrating on the structure kaadu manaki important. Here what is the thing? This is structure is not fixed, my dear friends. The structure is not fixed here. So that is the reason why it is called so simple. And it just depends on some numeric parameters of the data. Data lo unnatuvanti some numeric parameters meede idi ekkuva depend ayipotha untundi. Right, linear models are stable. And my dear friends, we learned just trees, right? If the data, we will find the best split here, best split. How do you find best split? According to the training data. And if the training data gets changed, automatically the entire tree structure will get changed. That is why trees are called sensitive. Tree models are sensitive to the data, sensitive. If you change, automatically the entire structure of the tree will get changed. That is why random forests are available. Random forest hunter. So I'll tell you in the next, but still, right? So that is why we call linear model or better or simple when it is right. Which is to say that small variations in the training data have only limited impact on the learner model. See, if there is a big change, then only you expect the linear model to behave in a different manner. If you have a small change, there won't be any change in the model. But if you come to tree, entire tree will be changed. This is the meaning of, right? Hope you understood, right? Next. Linear models are less likely to overfit. But whereas tree models are 100% possibility of overfitting. Whereas linear models are less likely to get overfit. But this also suffers from underfitting. Overfit and underfit. No, tree models suffer with overfit and linear models suffer with underfit. So when you overfit, when you want to avoid overfitting, then you go for linear model. When you want to when you want a model which do not have any underfitting, then you will go for tree models, as simple as this. See, linear models have low variance but high bias. So this is also an advantage, my dear friends. Low variance automatically reduces overfitting. Low variance reduces overfitting. High variance, on the other hand, for tree models, gives you overfitting. So this is how linear models are. High variance and low bias models such as decision trees are preferable if data is abundant and underfitting is a concern. If underfitting is a big concern, then decision trees are preferable. If underfitting is not a concern and overfitting is the only thing concerned, then linear models are preferable. This is how linear models. Let us, in this chapter, we are going to learn what are called least square classification. Least square classification and support vector mission, SVM, and some nonlinear models. We are going to have least square classification, support vector machine, and nonlinear models. Least square, my dear friends, least square, right? Now we are going into the subject concept. Univariate regression. My dear friends, these linear models are, by using this linear models, we can solve many ML problems like classification, regression, etc. So we are going with the regression, and this first type is univariate regression. Univariate regression, my dear friends. What do you mean by univariate regression? Right, before going to what is called univariate regression, let us learn what are the different forms. Right, this is of the form f dash is equal to x transfer x to r from examples xi comma f of xi. This is so. F cap is a prediction. F cap is a prediction. X to R from the training data. Xi is applied to, it gives you f of xi. Xi is called independent. F of xi is called dependent. See, this is xi and this is f of xi. Now we get f dash. No, we get f dash. So when we have xi ఇచ్చినప్పుడు f of xi ఒక పాయింట్ ఇక్కడ వస్తుంది. So we'll get different points here, different points. So if xi is varied, f of xi also gets varied. If xi is varied, f of xi also gets varied. Now we find f hat. Right. What is the difference? Residual. Right. Suppose we are talking about linear models, my dear friends. That is, linear models are only two. One, line or plane. Line or plane. For suppose, if we get, for suppose, and graph is plotted between fx and f of x. Suppose if you get points like this, so now if you draw a line, so which pass through most of the points. So what do you say? I say that all points are on this particular line. That is what f hat. My f hat. No, if I say f hat, whatever you give the value of x, f hat of xi lies only on this line. I say that. That is my prediction. But actually, see, some points are not on this line, are outside of this line. But we are predicting approximation only. So this error is called residual. This error is called residual, my dear friends. Residual. This error is called residual. How it is represented? Epsilon I is equal to f of xi minus f hat of xi. F of xi, no, modulus will be there, f of xi minus f hat of xi. Now the least square method, the least squares method finds f hat such that sigma I is equal to 1 to n epsilon I whole square is minimum. Epsilon I whole square, because this gives you negative value as well as positive value. Sometimes this tends to negative and this tends to positive. So that's why if you take squares, then there is no need to consider the symbol positive or negative. That's why we are taking epsilon square, epsilon of I square. Now least square method finds f dash such that sigma I is equal to 1 to n for all points. We calculate epsilon I whole square. For example, if there are 1, 2, 3, 4, 5, 6 points, then we will calculate first point is distance is 0, second point distance is 0 square, third point distance, suppose if it is 0.3 whole square, plus fourth point 0 square, plus fifth point, if it is this is the fifth point, if this is the fifth point, then it is minus say example 0.7 whole square plus 0 square. So this is called right, minimum. How do you say minimum? Right, that is what, right? This is one line, my dear friends. We can draw many such lines. This is one line, and another line also can be written just like this. Another line can also be written like this. Many number of lines can be written like this. No, whichever line gives us the minimum error, that line is called best line. This is how minimum least square method is explained. Least square method. And if this method is applied on a single feature, that method is called univariate regression. Univariate regression means which apply on a single feature. It is called univariate regression. We will see in the next class. Thank you.